First Spin. Welcome to First Spin, a show where I learn how to use the parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of two experts.
Hey, I'm Whisker from Toymaker Television, and I think we've got...
And I'm Roy.
Roy.
From nowhere.
Roy Eltham from Roy Eltham's Awesomeness.
The same Roy that has been here for 20-something episodes
Isn't
before.
that crazy? We're nearly at the halfway mark.
Halfway mark
of
to what?
I don't know, half of a year, I guess. 52 weeks, nearly at 26, right?
Yeah. I guess that's true.
Yeah, that's kind of crazy. So last week we talked about how we were going to do things slightly differently since we don't actually have... Well, we could go through the manual, but we'd end up going through like each of the what do they call it? Commands individually, and that would probably take just too long.
It's kind of boring for most listeners, I think.
Correct.
So we're getting into like practical knowledge and stuff now.
Correct. And so I thought, why not go through some of the modules from Parallax? And the first one that, so I think last week you suggested either the 5-position switch or the ping sensor, correct? Mm-hmm. And the ping sensor, I'm popping here, but the ping sensor looks like Wally, so I thought
it was cuter, so you chose that one?
Yeah.
Oh.
Because it looks like two eyes. And
way to enhance stereotypes, Addie.
Dude,
why am I not surprised?
It's not about stereotypes. I mean, you know, burly Whisker you can appreciate this, right? Look.
Did you guys see the picture that Parallax put up for heading off to Maker Faire?
That was very cute.
They had a little Bobot that had a like a hobo stick with a handkerchief tied to it. They say they were getting packed to go to Maker Faire.
Maker Faire or bust, I believe.
And if you looked closely, it was actually the new Bobot shield with an Arduino.
Oh, okay. Gotcha. Very cool.
But yeah, because those are more popular with the Maker Faire crowd in general. But
right.
But Parallax going to be in a booth there sharing all their stuff. It'd be cool.
I'm wondering, do you know where they're going to be?
They're in booth number 54 inside
54.
the main thing.
Very
They've been tweeting and posting messages on the forum about it.
Yeah, so hopefully if you guys are
you can
going
tell that
to
they've
Maker
got
Faire,
they've got some more creative people working over there on the Twitter account and such, because they're starting to do more and more of that sort of absolutely adorable stuff.
Yeah.
I having been to Parallax now, I can guess who's responsible for some of that kind of stuff.
Kenner Chip.
No.
No. I will actually be at the Maker Faire.
Yes, Roy, the super expert will be there.
Yeah, so if you guys are going to Maker Faire, pay attention for Roy.
Yes.
He'll be the dude in the fancy dragon t-shirt.
Correct.
Yep.
And
I've got my fancy dragon t-shirt all lined up for next weekend.
Excellent. So, okay, we should probably get on to the meat of the show.
Oh yeah, you got any questions?
The cute ping. So this is the ping sensor from parallax.com. And do you know how long it's been out, Roy?
Oh, it's been out for a really long
Years,
time.
right?
The current version, I think, is like the 3rd rev.
Oh.
Maybe it's 2nd rev. I mean, they've done a minor rev or two to it over the years also to improve it slightly.
Okay. And I'm looking at the code right now, and it says version 1.1 was updated in March 20th, 2007. So that's like 5 years ago.
Right, and I believe it was already a year or two old by then, if not longer.
Oh.
It's one of their first sensors, if I recall correctly.
Okay.
Like really early on.
Cool. So I pretty much got the code from the Kickstart website, and Kickstart is like, I don't know it fully, but it's on learn.parallax.com/kickstart. And it's got all like most of the sensors, if not all of them, and then demo code as well as wiring schematics for how to like hook everything up
on a breadboard.
On a breadboard, yep.
Right, or like the BOE board for basic stamp, or the
prop
propeller
BOE.
BOE.
Yep.
And they also have Arduino hookup and code for the Arduino.
Yep. So it's really, really handy to get started and to actually look at the code. Now, the one thing that I've noticed is that I kind of hesitate on is that it relies a lot on object code, like, using objects. And that's fine for people who don't necessarily want to look into the guts.
I don't think they mentioned it, but for those of you who might not know, the ping sensor is a very simple ultrasonic transducer and receiver setup, and it's typically used for gauging distance. In various electronics projects. It's just a really easy way to use ultrasonic sound to get rough distances.
Right.
Yeah.
So
it's reasonably accurate down to, centimeters or some number of millimeters.
I'd say it's one of the most recognizable Parallax products. I mean,
right.
Because it's on
been
a
around
lot
forever,
of
and it's
robots, right?
It's pretty ubiquitous. So I'm sure most of the listeners have heard of it. But in case there's anyone out there that doesn't specifically know what the ping is, that's what it is.
Right.
Right. And one of the nice things is it's actually really ultra simple to use. Like it just has one pin, and you just toggle it high and then back low, and then listen, and it's super simple on that regard.
So we're gonna have to go through that because. I know when I was working with it, like the Kickstart demo code is easy enough to, copy, paste, run, and then bam, it works. But that's not exactly, you guys know that's not exactly how I work.
Yeah,
I want to write the code myself without an object.
You also want to like analyze the object that they were using and figure out what the heck it was doing inside there.
Correct.
She started doing that a bit this week. And she and I had a little interaction where we pretty much agreed that we kind of both like making our own drivers more than we like analyzing other people's, because it just takes less time at the end of the day.
Forever.
Sometimes.
Yeah. You guys tend to be more of a do-it-yourself. You want to learn how to do it and write the code yourself.
Yeah.
How dare you?
Because part of it is
some people are a little more open to the idea of just using something that's already written to help them along, and then spend their effort on the code that uses the driver instead of the driver itself.
But then couldn't the driver end up being bloated?
Well, there's all kinds of issues you could run into, but there's also all kinds of positives. Like some of the drivers have been tested and updated and edited by users over the years to be
true,
really good and vetted out with all the problems and added features that people have wanted and needed to use. So they're good. Some of them are not quite so much like that. Some of them may even have bugs.
True.
Addy always seems to pick the ones that have bugs.
It's very odd. So just to warn folks, when you're looking for some of these modules, sometimes you'll end up coming across old versions of Parallax's website, and that's where you'll find a lot of faulty code, as I've found on a couple times.
Yeah, you have to make sure when you're doing your searches that you're hitting their current sites, and not some cached old thing.
Right.
And also it's just helpful sometimes to just, instead of searching to find it, go to their store and go to the page for the object and get the latest link.
Correct.
Or go to the forums in some cases, because some people have made newer stuff than what's linked on the Parallax site.
Correct. Yep. So, okay, let's start with what I do know.
Okay.
So the ping sensor is a sensor where you stick it on a breadboard, you wire it up. There's 3 pins. It's very simple. There's ground, there's your power pin to 5 volts, and then there's your signal pin.
Right.
It's got 2 little eyeballs, and essentially when you get it all hooked up and all the code's working well, you put something in front of it and it'll tell you in inches, centimeters, or millimeters how far that object is. So if I put my hand in front of it, like
Right.
in front of it
Well,
5
let's back up
inches,
a
then
step. The code you're using will tell you how far. The ping itself doesn't tell you a distance.
true. That is a good point.
You have to write code to figure out the distance based
Right.
on the signal you get back from the ping,
Right.
which we can go into in a minute.
Right. Like how it actually works.
Right.
You know how it actually works?
I do know how it actually works.
Expert.
I
All right, cool.
mean, I know how it works enough to explain it in this sense. I mean, I don't know the nitty-gritty details of every component on that little ping board, but
Well, that's fine.
I know enough of how it works.
Just the
Right.
generics I'm okay with. I'm okay
Right.
with the generics. So would it be easier to explain how it works without talking about code yet?
Yeah, it'd probably be, simpler to say the mechanics of the device itself first, and then we
Okay.
can go into the code for how you would use it, because then people can kind of understand, like, whatever processor they're going to use, they know what they need to do at a concept level.
Okay, sounds good.
So the ping has, like you said 2 eyeballs. It's 2 transducers
Yep.
that produce ultrasonic pulses, and
Yep.
they actually only produce a pulse with one, and they listen for the return pulse on the other one.
Oh.
Some ultrasonic sensors just have one transducer and they pulse with it and then listen with the same one. But Parallax chose the two version model because it was able to, work a little. I
Maybe
think
more
part of the
reliably.
reason. Well, I think part of the reason is it actually is able to work for shorter distances better. Because one's always listening and one's the sender, and so you don't have to switch the mode
Sure.
from sending to receiving. That might be a factor. I don't really know their design. I don't know the engineer that made it or anything, so I don't know what their philosophy was, but it's fairly common. You see a lot of the clones and copies are 2 transducers.
Okay.
So anyway, what happens is your signal.
And for those of you who may not be too familiar with the technical term, in a transducer, you're just talking about something that translates from one type of energy to another. In this case, you were translating from electric power to an actual vibration in the air. So essentially, one of them is a speaker that chirps, and the other one is a microphone that listens for chirps.
With ultrasonic awesome.
And the frequency that it pulses at in this case is a 40K hertz frequency.
Which is up above human hearing.
Okay.
Yeah, it's ultrasonic. That's why they call it ultrasonic. It's
Could I detect
above
bats
sonic.
with this?
I think it's
Bats would
even
detect
higher than what they
bats.
use.
Oh.
Human hearing rolls off somewhere above 20K. And Roy was saying like 40K.
Yeah.
You're probably going to annoy some cockroaches with this.
Gross.
So there's actually a little tiny microcontroller on there on the ping sensor, and when you set the signal pin, you had your power and ground, and the signal pin, when you set it high, it's triggering the device. So you set it high for a moment and then set it back low.
Now, setting it high as in it's putting in output.
Right. So when you have it hooked up to your pin on your microcontroller and you set that pin to a 1 as an output,
Yeah.
it will set the pin high, which triggers the ultrasonic pulse, and then you set it back to low, which I believe it's at the point that you actually go from high to low that it triggers and sends out the pulse. And then what happens is you change that pin from being an output, where you set it high and low, to being an input, and you listen. You wait for the pin to go high, and then when the ping goes out, the ultrasonic chirp goes out and comes back. When it first goes out, that's when it sets the pin high as an input. On your input, that pin will be set high from the ping, and that's when you start counting. And you use your system counter to count how many ticks go by while that pin is high. And then the chirp will go out and come back after bouncing off of something, and the other transducer will hear it, and the ping sensor will set that pin back to low, meaning it got the chirp back.
So the chirp out and the chirp back all happens between when the pin goes high and when it goes low.
Right. When it all happens, so let's back up to make sure you understand it. When you set the pin high and then low, that's not when the chirp happens and comes back.
Oh,
That's just you telling the thing go,
okay.
saying, I want you to do a detection right now. I want you to send out the pulse and tell me how long it took.
Okay.
Okay. And then
That is
so right. So that's the trigger. That's like you push the button and said go,
okay.
right?
Okay.
Then you set the same pin to an input and listen and wait for it to go high. And when it sets that pin high, which will be a slight delay later. So
Wait a minute.
so you set the trigger.
Okay,
And
so
okay.
so
It's not that
confused.
complicated. I think it's just
We're trying to get to the details. I know. Okay, so you set the pin
as
an
an
output,
and
then you set it as an
high.
input.
Well, first you set it as an output, and
then
you
set it
toggle
high,
and then back low. So you set it high, and you wait a moment, and then you set it back low.
Set it high. No, wait. You set it as an output.
Set it to an output. Set it high. Set it low. Set it to an input. When the unit pings out, it sets it high, and when it gets the echo back, it sets it low.
Right.
So your code is detecting the time in between when it sets it high to when it sets it low.
Right.
When it sets it high and when it sets it... What?
So so there's two directions here. At the beginning, you are talking to the ping sensor on the one pin. You're saying you're setting the pin high and then setting it back low with the pin in output mode. So you're telling the ping to go. Then after you've done that, you set the pin to an input, the same pin, and you listen using the wait commands, in this case for the propeller.
Okay.
You wait for the pin to go high, and the ping sensor at that point is talking back to you. And when it sends out the chirp...
What do you mean you wait for the pin to go high?
Right, the ping sensor will
set... PEQ, was it?
Wait.
Well, you can wait PNE or PEQ depending on how you set it.
You guys are getting into the code. Okay.
What do you mean? What, huh?
You're getting into the code.
Right, no, but
you've learned that.
But the basic concept is that whatever controller you're using, you might be using a different controller where all you do is you read the pin continuously until it goes high, right? That's one way to do it. I mean, you're just waiting for the pin to go high, and the ping sensor is the thing that's going to set that pin high. When it sends out the chirp, it's going to set the pin high. So you'll read a 1 on that pin.
You mean when it receives a chirp?
When it sends the chirp out.
Yeah.
So from the point that you set the trigger, so when you trigger it, you set high and back low, it has a small delay, allowing you to set the pin back to being an input so you can listen. And then that small delay elapses and it sends out the chirp. And when it sends out the chirp, it sets the pin high to say, start counting now. Okay? You follow?
Okay, so it sends...
I hear crickets, so...
sends out the chirp, and that...
sets the pin high.
Sets pin high. Okay.
So, like I said, there's a little tiny processor on the ping that's doing this work.
Okay.
Right? It's setting one of its pins high to signal out on that pin, the signal pin, to say, hey, I sent the chirp out now.
Okay.
Right? So then the chirp goes out,
yeah,
and the pin is still high, and then the chirp bounces off of something and comes back.
Yeah.
And the little processor that's on the ping sensor is waiting to hear that chirp. And as soon as it hears it, it then sets its signal pin back to low, which you will read as your input pin will now read as a 0 to go back down to 0. So, and during that time that it was high, from the point when it switched to high, and then the point until the point that it switched to low, you count. You use a counter to count how long that took. How many ticks went by for that pin to go high and then back low.
So high is when it sends the chirp, low is when it receives the chirp.
Yeah, it goes back to low when it receives it. And there's actually an additional.
Wait. It
Yeah,
goes back to low and receives it, or it receives it and then goes back
it
to low?
receives it and sets it to low.
Okay, because there's a
Once it's
difference.
well, it's simultaneous, right? It
Right.
receives
Well,
it and the pin
yes.
goes low.
Yes.
It's like nanoseconds apart, probably,
Right.
or maybe a microsecond or two apart.
But that's the thing. There's a difference in how you say it.
Well, yeah, okay. But the key thing is that all the ping sensor is doing is telling you how long did the chirp take to travel out and back to the sensor. Right? That's all the sensor does. It's very simple.
Okay.
It's just setting a pin high for the duration of the time that the chirp
is out in the wild.
Chirp travels out and comes back.
Right.
Now there is a caveat in that it will time out, like after I think it's 20 milliseconds or something. If it doesn't hear the chirp back, it just gives up and sets the pin low.
Oh, can you change that?
You can't change how long the ping sensor will
times out.
Go. It just times out after a certain amount of time. It just gives up and goes, okay, I'm not going to hear anything, so I give up.
Okay.
And it will set the pin back low, and that is, well beyond its maximum distance that it is reliable at.
Yeah.
For measuring.
Yeah.
So if you get that time, you just know that it didn't detect anything.
I see.
So you just use that as a test case. If your time is greater than some number, then don't count it as measuring anything valid.
So, like Roy said, this is the propeller sends kind of like an impulse or a message to the ping that says, hey, I want you to do something. And the ping says, okay, I will go ahead and do said thing, measure where your hand is in front of my two eyeballs. So the way it does this is the propeller will so there's one pin that the ping sensor is connected to on the propeller, and the propeller will set that pin as an output. Then it will set that output as high, and that'll bring power to that pin, whether that's 3.3 volts, 5 volts, whatever, and essentially send a 1. And then it will set that pin low, which will remove power and will essentially send to the ping a 0. And then it will make that pin an input. So output, set the pin as an output, send a 1, send a 0, then set that pin as an input. And when it sends that pin as an input, then the ping sensor responds and says, oh, I see that you've sent me a 1 and a 0. 10 points for awesome, right? And then the ping says, okay, fine, I will send out a chirp. And then at the same time that I'm sending out a chirp, the pin will be set high by the ping sensor. Mm-hmm. And the propeller will, according to the code, measure or record what time it is. And then when the ping sensor receives that chirp back, the pin will set the pin low, and then the propeller will know to record that time point. So essentially what you have on the propeller side is how long it took for that chirp to leave and come back.
Right.
Is that about right?
That's correct.
Okay. So, I mean, I know I'm beating a dead horse by this point. Okay.
That's fine. It would take somebody longer than a half an hour to figure this out on their own. So, no big deal.
It's because, yeah. So one of the questions that I had was why the propeller couldn't have just sent out 1 and then, like, not the 0, just sent a 1 and then made the pin an input. So does that make sense? So output, then 1, then input. instead of
Right.
output 1, 0, input. And
So part of the reason for that is electrically what you would be doing then is you would be energizing the pin and the signal going into the ping with some power. And while it's still powered, you're going to switch the pin to an input. And
So
that
that's-
happens really, really fast. And it's still got power on that line. And it might accidentally read that as being high, even though it's not really supposed to be.
I see. So the ping sensor will be like, well, you didn't clean up after yourself.
It's not the ping sensor, it's the propeller. If you set a pin to high in output mode and then just immediately switch the pin to an input without doing anything in between, you might momentarily read it as high because the propeller was driving it high for a moment. And then if there's some capacitance in the signal somewhere on that pin, which there always is at least a little bit, then there'll be a slight amount of time for that power to go from the 3.3 volts that the propeller outputs back down to 0. So during that time, you're reading it as an input. You'll mistakenly read it as high and think that the ping started going, but it hasn't yet.
Okay.
So that's part of the reason that we switch it back to low to get it into a good state to start with when we switch it to input.
Okay. So it's just a better electrical habit to get into.
It's a better circuit design, and it actually will work more reliably that way.
Okay. So what you end up with then is a
the start time.
You get the start time and the end time.
End time of how long the pulse took, and then you can subtract those from each other and get the total amount of time in our case the clock counts,
that
right?
The chirp has been out in the wild.
Yeah, traveling out and coming back.
Right.
And so then what you do is you take that and you the ping sensor comes with data that tells you how fast that pulse travels. It's basically the speed of sound, right?
So it's like distance over seconds or something.
Right. Yeah. And so you would take how many clock ticks went by and you go, okay, well, there's so many clock ticks per inch or per centimeter, and you would divide and get how long it went, right? The distance. But in that case, you would get the total distance of traveling out and back. So in order to get the distance to your hand, you would divide it by 2 so that you get just the distance out to your hand or to the wall or anything.
Okay.
So is that all making sense, Addie?
I believe so. And there's another way to think about it too.
Well, you might have to save that for next week.
Oh.
I mean, we could play story time next week, or we can answer more questions for you, whichever. I mean,
well, I was thinking we can go through.
You're kind of steering the boat.
Code next week.
Okay, we could do that too, but we are out of time for this week.
Okay.
Yeah.
So are you going to be working on making your ping do stuff this week?
Yeah, I've got a project in mind. I think you guys will think it to be very inefficient, but that is the point.
Okie dokie. Well,
cool.
You guys can find this show every Tuesday at firstspin.tv. And of course, we also want to be able to answer all of you listeners, your answer any of your questions too. So you can send those questions over to feedback@tymkrs.com.
Yes, please.
So until next week, bye.
Ciao.
See ya.